Let's begin this session from section 11.3, homework exercises number 6. Problem states 19 possible books. You plan to take 7 with you on vacation. How many different collections of 7 books can you take? Now, whether you take a book, whether it's the first, second, third selection, it doesn't matter. You're taking it with you on vacation. So because it doesn't matter when it's selected, what we're basically saying, order does not matter. Okay, order does not matter. So we know what? When order does not matter, it's a combination. And capital C, we have a total of 19, and we're selecting 7. So our answer is 19C7. The formula states it's the number on the left factorial divided by the number on the left minus the number on the right factorial times the number on the right. Okay, and again, you can do it on your calculator. If you're going to do pencil and paper, you've got 19 times 18 times 17, 16, 15, 14, 13, and then times 12 factorial. Okay, and then the reason I do, because 19 minus 7 is 12 factorial, those will cancel. And then 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. So you'll have to multiply these numbers and then multiply these numbers, 7, 6, 5, 4, 3, 2, 1, and divide the 19, 18, 17 times all the way down to 13 divided by the product of 7, 6, 5, 4, 3, 2, 1 and get your answer. Okay, hopefully if you've got the TI-8384, you can do it on your calculator a lot faster. And the sequence is on the calculator. We put the total 19, and then we go to the math, hit the math key below the alpha, and then the right arrow 3 times to highlight probability. Remember, we're doing probability. This is the section on probability. It's a combination, right? Order does not matter, which is number 3. Or you can go down to number 3, hit enter, and we're selecting 7. And then it automatically has the formula built in, and you get 50,388. So if we multiplied those numbers together and did it, we would get that same answer using pencil and paper. Unfortunately, calculator will do it for us. All right, very good. Number 7, you volunteer to help drive children at a charity event, not to the zoo, but you can fit only 7 of 19 children present in your van. How many groups of 7 children can you drive? Okay, so we have whether the child is picked first or second or third, they're going to get they're going to be able to go in your van. Same thing happens to whether you're picked first, second, or third, or 7th child. So order does not matter, right? Okay, it does not matter. So it's a combination. And we have 19. Whoops. 19 is the total of children, and we're fitting only 7, so 19C7, which is exactly the same answer from the same numbers from the previous problem. You probably won't have the same numbers, but again, it was 19 factorial divided by 19 minus 7 factorial times 7 factorial. That's the formula for combination, and you can do it on your calculator. You'll get 50,388. Okay, or you'll just have to write out the factorials and cancel if you don't have a calculator. Okay, so we have 50,388. Okay, just happened to be, I got the same numbers from the last problem, and it was a combination. To win at Lotto in one state, you must correctly select 6 numbers from a collection of 50 numbers. The order in which the selection does not matter. So they tell you order does not matter how many selections are possible. Order does not matter. So it's definitely a combination. You've got the 50, and then you've got 50 to work with, 6 to select. So again, it would be 50 factorial divided by 50 minus 6, and then another 6 factorial formula for combinations. So that would be 50 times 49 times 48 times 47 times 46 times 45 times 44 factorial. 50 minus 6 is 44 factorial, so I stop there because those will cancel. And then 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. So you multiply these numbers, get the product, multiply these numbers, and then divide the product of 50 down to 45 divided by 6 times 5 times 4 times 3 times 2 times 1, which I believe is 720. Okay, so again, you can do that. You'll have to do that if you don't have a combination key. If you've got the calculator combination key, we can go ahead and do it. 50 is the total numbers, math, and then over to 3 places on the menu at the top to highlight PRB, probability, choose a combination because the order doesn't matter, and we're selecting 6 numbers. So 50 NCR6, combination 6, that's the problem, so we put it in, and believe it or not, that's why it's very difficult to win the lottery. It's 15,890,700 different selections, okay, of 6 combination of 6 numbers from a total of 50. All right. Number 9, in how many ways can a committee of 3 men and 4 women be formed from a group of 9 men and 10 women? Okay, now this one is a little bit different from the previous ones because we've got men and then we're selecting women. So what you have to do is you have to find a number of ways to get the men, then find a number of ways to get the women, and then you selecting these 2 together, so you're going to multiply these 2 answers, okay? So the number of ways of selecting the men, you're going to keep the men separated. You've got to get 3 men from a total of 9, okay? Sorry, this is a little bit off here, the writing. So it's going to be a combination for men, order doesn't matter. We've got a total of 9, and we're selecting 3, okay? So 9C3 for the men. For the women, again, 4 women, order doesn't matter, so it's a combination. It's a total of 10, and we're selecting 4, so 10C4. So we're going to do each of these combinations, get an answer for this, and then 9C3, then 10C4, and then multiply those 2 numbers together, whatever they are, and then that will be our final answer when you multiply those 2 numbers together. So again, when you got 2 different groups, you've got to do the combinations for each of the group separately. 9C3 because 9 men, you're picking 3 from a total of 9, and 10C4 for the woman is 10 women, and you're picking 4. Okay, so we're going to do each of those on the calculator. Okay, and then we'll multiply them together. So we got the first one is for the men 9 math over highlight probability. It's a combination, and we're selecting 3 men. So for 9C3, the number of ways to get the men is 84. The woman is 10 total, and again, it's solved with a combination because the order doesn't matter. So we go over to we go over to probability by using the right arrow 3 times, and then we're going to select number 3 or hit number 3 for a combination, and we're selecting 4 women. All right, so 10C4 for the woman is 210. So we've got 210 times 84 for the number of ways to get the men, and we get a total of 17,640. Okay, and that is the correct answer. Very good. All right, let's look at number 10. All right, 54 Republicans, 45 Democrats, 1 independent. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? Okay, very similar to the one we just solved, the men and women. So again, we have the number of Republicans and then the number of Democrats. Republicans, there's 54, and we've got to select 3. So it's a combination 54C3. All right, my thing is a little bit off. Whoa. Whoa. Got a. Let's go ahead and get back here. If I can get here. All right, there we go. Republicans. All right, let's just go ahead and stop this session here because the computer's faulty. So I'll go ahead and start number 10 in the next session. So we'll stop here for number 9. If you have any questions, send an email to me, your teacher, Dr. Swerves, through the inbox, through the Canvas portal. And thank you for listening to this video. I hope you found it helpful.